Hello, this is Junichiro Horikawa, and today I would like to show you some basic workflow, how to communicate between Grasshopper and Houdini. Grasshopper is a Nurbs-based parametric modeling plugin for Rhino, and Houdini is a mesh-based precision modeling software. Could also be used for animations as well. So there are some benefits but using both softwares in different ways. If you want to deal with nerve surfaces or curves, it's better you use Rhino and Grasshopper. If you want to deal with mesh modeling, then it's better you use Houdini, in my thought. But there are cases that you want to use a parametric nerves curves modeled, used as a base for the mesh modeling. And it's a bit hard to do this kind of nerves-based modeling in Houdini. So what I want to show you today is to first do some curve modeling inside Rhino together with the Grasshopper, then bring it to Houdini to create a mesh like these, then convert it into a mesh network like these and export it back as a mesh object. Then go back to Grasshopper, import that as a mesh. And then in Rhino 7 beta, there is a component called mesh subd from mesh, which you can convert mesh into a subd. Then after that, you can also convert it back to a vrep, which makes its geometry really smooth and product ready. So that's what I want to do. Like creating this kind of smooth network from a curve is a bit hard to do in just using Rhino. So I think there is some benefits using both softwares in this way. So that's the things that I want to show you today. So let's do that. Okay, First, I'm going to create some simple geometries from scratch in Grasshopper. So I'm just gonna start with the circle. Divide the circle with the divide curve. Maybe I want to create more than 10. Let's set the maximum to 20 or something. All right, then let's create a line coming out from each point. I'm gonna use line SDL, and I want to create a perpendicular lines from each point so I can use this tangent vector. I think first of all I'm going to rotate the z vector using this tangent as a rotation axis with a angle half pi, so that means 90 degrees. Okay, I'm gonna convert 90 to radians, then use this for the direction for the line, and from the starting point P, and I can also define the length of that perpendicular line. Maybe I can set it to maybe 100 for now. Okay, connect that. Right, now this itself isn't that interesting yet, so I'm going to rotate this line using this circle as a rotation axis for each point. So to do that, I can still use this tangent vector as a rotation axis. So let's do the rotation using, say, rotation axis. Okay, rotating this geometry, and maybe I can use rotate 3D. Okay, and the x is the axis, so let's connect the tangent right here. Then the starting point, the rotation point, should be at each point right here, and the angle, that could be a multiplication of 2 pi, meaning 360 degrees. So, and I can use this t as a parameter. So in order to use this, let's reparameterize the curve as well so that the range will become from 0 to 1. I am going to multiply or maybe remap this 0 to 1 into a multiplication of 2 pi. So let's first create a 2 pi, which means a 360 degrees, and multiply it by some integer value so that you can control the number of cycles, say 3 for now, and then connect it to t, and then connect it to an angle. And as a result, you'll be able to control the angle for each lines. Maybe there are 2 less lines right here to see the effect. Maybe I can increase the number to maybe maximum 100 to see the result. Yeah, that might be better. Okay, now let's also shorten the line lengths, and finally I'm going to connect the endpoint to create another curve using an interpolated curve so that it will go through the points, each point. Let's also close this. Okay, like this. Okay, and I am going to also reconstruct the circle using these points so that each point will be connected or go through, so that you always have the control points on the end of the lines right here. Okay, so now I have 3 types of curves. One is these lines, one of these network on the outward curve, and the one on the inward circle. So let's combine these together. Line, outside curve and inside curve, and let's flatten this. And what I want to do next is to export this curve as a file which Houdini can read, open. And the one of the file format that Houdini can read as a curve data is the IGES data, which is a CAD format, one of the CAD format. So let's convert that. Let's export this into IGES. And in order to export the file using a Grasshopper, there isn't a default component for that. So I am going to use the component that I made myself using a CSharp, which is uploaded under a GitHub repo of myself called Grasshopper Programming Tutorials on 15 export geometry with Grasshopper and 16 import geometry with Grasshopper. So the 15 is for is the one that shows how you can export the geometry inside Grasshopper using C# component, and 16 is the one to import the geometry using C# component. So if you open that file, what you see is these component. So I'm going to just copy this. You can do the same. This is the export component, so I'm going to copy this C# and then bring it back to the one that I was working on, which is this one. Connect this. Let's also copy the import, which I will use it later on, which is this one. So I'm going to import this one as well. And then go back to a current file. Now, instead of using button, I'm going to convert it into, I'm going to change this to toggle since using buttons sometimes have some problems. Alright, now it's the time to first let me save this Grasshopper file. I'm gonna name it gh2houdini2. Okay, then first thing you want to define is the place, the directory you want to save the file to. So I'm going to right click this to this file path node, file path component, and choose the select directory, and then I'm going to choose anywhere you want, but the place that I'm going to choose is under Grasshopper 2 gh file, and well, you just choose whichever place you want. I'm going to choose this geo folder. Right, then I'm gonna name this to any name you want, but something that you can remember, something like ring2.iges. What's important that you include this extension iges, which is a CAD format which you can read it as a curve data inside Houdini. So after you have set up all the parameters, double click this toggle to export and see if the file has been successfully exported. And this is the file that I have just exported, ring2.iges. Now it's the time to import into a Houdini. So let's create some new files. And then first let me save the Houdini file. I'm gonna name it thicken2. Okay, and let's create a geometry. In order to import the file, I'm going to use file node, select the ring2 that I have just exported from Grasshopper. We'll give you a network. Now it is right now closed, but you can make it open later on. If you want to open at this point, you can use a primitive node to convert it into a open curve like these. Okay, now currently the curves is set as Nurbs curve. In order to convert it into mesh, you need to convert it into polyline inside a Houdini. So to do that, you use resample node. It's similar to a rebuild component inside Grasshopper. Now you need to choose the length of the step for the conversion, and you can check the resolution by turning on this point toggle on. I'm gonna set the 0.5, maybe that's too big. Maybe 10, maybe that's too dense. 20 might be good. 30. It's better that you make as less point as possible, because at the end you just going to convert it into a sub-D geometry using a subdivision method. So less points the better, unless you don't lose the overall shapes. Okay, 40 might looks good. Now you also want to check this resample by polygon edge in order to preserve the endpoint, the control point position. Right, looks good. Now you also need to fuse the point so that each point will stick together, welded together. Okay, so looks good. Now it's the time to create a mesh network, line network using those curves. And what I'm going to use is the polywire. Okay, And let's set the radius to something really thick, like 10. Looks good already. Now I think this is all good. Now let's export this back into as a mesh geometry input back inside Grasshopper. So in order to export this to a mesh geometry, what I'm going to use is a raw geometry output node. And let's set the directly and set the file name to say ring2.obj. Right, one of the mesh file extension. Okay, now click this button, save to disk, and which will save the file. Okay, where did it go? Okay, right here, ring2.obj. So let's go back to the Rhino again, to Grasshopper again, then import this geometry as a mesh geometry inside Grasshopper. So I'm using this CSharp component that I made, copied from the file that I created before from GitHub, which is uploaded on a GitHub. Now first select the files using this file path, which is inside a geo, ring2, open it, and then double click this toggle, first toggle called import. We'll import the geometry as a mesh object. You can retrieve the mesh object from this geometry output. Now what you want to do next is to convert this into subd using a subd from mesh. And as a result, it will convert the mesh into a really smooth subd geometry. Then if you want to convert into a brep, then you can just connect this brep node, brep component, and that's all you need to do. Now let's also preview this with some colors. Say some bluish color, like these, right? And if you bake this, what you get is a brep geometry, which then you can send it for like manufacturing or anything with this clean geometry. Right. So that's the basic process you can do between a Grasshopper and Houdini. What's good about this process that once you have set up the network like these, like for example, if you want to change some parameters later on, like increasing the number of lines or decreasing the number of lines, changing some parameters like these. Say if you want to have this geometry being updated as a mesh again or brep again, first you want to send it into a Houdini or as an IGS. Then inside Houdini, open that file using reload geometry from the file node, then export back as an obj. And inside Grasshopper, double click this import toggle, which will import back what has been made inside Houdini, and voila. Now there are some steps you need to do, like clicking the reload button or so on. If you want to automate this as well, you want to we're gonna talk about the using of Python language in order to do some communication between two softwares in real time. But to make it simple as possible, this is the way you can I can think of communicating between the Grasshopper and Houdini. And yeah, here is the way. So maybe next time or sometime I could try using like Rhino.insight for Houdini, or creating some custom Python script in order to communicate between Grasshopper and Houdini in real time. Might be also an interesting topic. But with people who doesn't have much of a programming background, this will be the easiest way to communicate between Grasshopper and Houdini. Okay, so that's it for today, and I hope you like it. If you like it, please consider subscribing, and I'll see you next time. Thank you.